Okay, hi. Now we're gonna talk about a per unit tax, okay, on the firm, okay, and how this is gonna affect our marginal cost curve as well as our average cost curve. Okay, this is actually in response to my cost curves video because I have this friend from NUS. His name is Kenny. Okay, he spotted out one of the mistakes they actually made. A per unit tax is actually not a change in the variable cost in our production. So we cannot take it that just because there has been a unit tax that is imposed onto each unit of production, okay, it's a change in variable cost. Yes, it may sound like a change in variable cost, but I will try my best to explain to you why this is not the case. Okay, so before we go into anything further, just let's refresh our memory on this. Okay, our total cost curve, okay, is going to be used to derive our average cost curve as well as our marginal cost curve. This is average cost and this is marginal cost, total cost. Okay, so now if we are going to have an equation for the total cost, okay, assuming that total cost, alright, I'm just going to use a very simple equation, okay, to not complicate things. We'll have a multiplied by x squared, okay, plus x bx plus c, okay, where a, b, c are actually constants. Okay, so when we divide total cost by x, okay, what we get is actually average cost. Okay, so let's just go and do that. Okay, divided by x. Okay, we divide this, so you get ax plus b, okay, plus c over x. Okay, so that's what we got, and we know that the minimum point, okay, of the average cost, okay, always intersects the marginal cost. Okay, they both intersect at this point. Okay, so let us find out what is this minimum point first. Let us find out the quantity of x, okay, that is this minimum point right here. So how do we do that? Okay, we take the average cost curve, the equation, and what we're going to do is we're going to differentiate that in respect to x. Okay, so average cost equals to ax plus b plus c multiplied by x to the power of minus 1, because you bring this up, it's going to be minus 1. Okay, so let's start off from there. Right, so we're going to differentiate ac in respect to x. You're going to get a, this is going to disappear. Okay, you're going to get minus c x to the power of minus 2. Okay, so this is what you're going to get. You're going to get a minus c to the power of divided by x squared. Okay, and so we know that to find critical points like this, you know, where it's a minimum, right, you just let this whole thing equals to 0. Okay, so AC, differentiate AC in respect to x equals to 0 equals to a minus c x squared. So let's bring that a across. Okay, so here we got a negative here, and then we got a negative here again. Okay, so let's bring this over the other side, and we remove away all the minuses, so you get x squared a equals to c. Alright, then x squared equals to c over a, and x equals to the square root of c over a. Okay, so take note of this part. Okay, this is important. Okay, so basically this is the minimum point, okay, of the AC when we do not have the unit tax. Okay, now when we introduce the unit tax, okay, look at our total cost curve again. Alright, so total cost, okay, equals to ax squared plus bx plus c. Okay, now we know that this is the fixed cost. Alright, and we know that this is the variable cost portion of the total cost. Okay, well, if there's been an endogenous change, like maybe the change in price of labor or capital, then this will be affected. Okay, all these things, yeah, will change. But if there's a per unit tax, it's something that's added on. So what we got to do is we got to plus tx, where t is actually the per unit tax. Okay, so let's do the whole process again. Okay, and I'll show you exactly what's going to happen to the AC and the MC. Okay, so alright, so remember this equation. Okay, TC equals to ax squared plus bx plus c plus tx. Okay, so what we're going to do now is we're going to divide this by x to get AC equals to ax plus b plus cx plus t. Okay, and to find the minimum point again, what we're going to do is we're going to differentiate AC in respect to x. This is going to be gone, and well, this is equals to cx minus 1, so if you differentiate that, it's going to be minus cx minus 2, and this is going to be gone. And what we have here, if you equate this to 0 again, so it's going to be minus cx minus 2 equals to minus a, and if you solve for x, okay, let's not be lazy. Okay, just give me a minute. Equals to a, okay, you bring this to the other side, there will be x squared, a equals to c, then this will be x squared equals to c over a, and x equals to square root of c over a. Okay, so looking at this part, okay, this is exactly the same as this. So since these two things are the same, okay, which means that the change to my average cost, minimum point, is over here. Okay, now we know that this is what the hell was that? C over A, right? So if both are the same and there's been an increase, okay, obviously there's been an increase in average cost because this equation right here is definitely bigger, okay, than this equation right here. Okay, all right, because there are more components. Yeah, you can see that, right? Okay, so we know, since we know that, all right, and because of the addition of t, it's gonna shift up directly, just like this. Okay, and the distance between here and here, all these distances, is actually t. Okay, so like what I mentioned in my cost curve video, I said that when there's an increase in variable cost, okay, I showed you how to derive the new AC and MC, where the minimum point will go up and you go left. Okay, but in this case, because of the calculations that I just showed you, when there is a per unit tax, it will go up vertically, okay, and the MC will follow suit. Alright, so yeah, I hope this clears the doubt, and I would like to thank Kenny for pointing this out to me. So yep, any queries, you can just message me and I'll be glad to answer. Thank you very much. And yes, the iPod is still up for grabs. Okay, so keep watching my videos if you want this. I think a girl would probably want this more lah. I don't know. I mean, I don't mind carrying this lah, but well, I mean, if you're a guy and you want it, it's fine. Just keep watching my videos, and you will catch the password. Okay, the password, it will be random. You know, you just appear anywhere during my videos. Okay, so yeah, nice iPod, man.